So today we will discuss about hybrid renewable energy standalone systems. Okay. So as you can see the outline of the presentation, first we will be discussing introduction, global warming situation in North Canada and Quebec, optimizing the use of diesel generators. So this thing is very important because there are so many communities in the north of Canada, north of Quebec, they are not connected to the main grid. And those communities are 100% dependent on diesel generators for many decades. For many decades, they are using diesel engines. So, why? Because during the winter time in the north of Canada, temperature may go to minus 40, minus 50 degrees centigrade. So, if you use 100% renewable energy and during the night time there is no sun and if there is no wind, so it will be very difficult for the people to survive. So they are using diesel generator for many generations. Now the efforts are being made to optimize the use of diesel generators because it is polluting a lot, it costs a lot of diesel consumption. So efforts are being made to reduce the dependence on diesel and to reduce the cost by integrating the renewable energy sources with the diesel. So those are standalone system, right? So we will see wind and solar radiation profiles in Canada and Quebec. Problems related to renewable energy sources, wind energy conversion and exploitation technologies, microgrid in hybrid standalone systems, and then we will discuss different configurations of hybrid energy-based standalone systems. So many researchers, engineers, companies are working on hybrid standalone systems around the world. And few years back, we were doing a survey and we found that 60 different types of configurations are already being used by the engineers around the world. So it is very interesting thing to see. So coming to the global warming, as you know, year 2024 was the year of record heat. 2025 was not that hot as year 2024. And then we are talking about the pre-industrial temperature, 1880, when we started keeping the meteorological data, temperature data, weather data, all those things in 1880. So efforts are there that we have to keep less than 1.5 degree. It should not, temperature rise should not go above 1.5 degrees centigrade above the pre-industrial temperature. And if we don't do that, then it may be very catastrophic for the whole world. And why it will be catastrophic? Because many island nations may be finished. Okay, so decade 2010 and 2019 was the hottest decade ever recorded. And now 2020 to 2029 may break that record. So that's why around 10 years ago, December 2015, a conference was organized. This conference is going on for many decades, and that was 2015 was the COP21 conference organized by United Nations in Paris. An agreement was signed. 196 countries signed that agreement, and that is called Paris Agreement. And in that Paris Agreement, what was decided, that we have to keeping the rise in temperature below 2 degrees centigrade above pre-industrial levels, 2 degrees centigrade. So at that time, 10 years ago, they said, okay, 2 degrees, because people were not agreeing to 1.5 degrees centigrade. So that's why, because everybody had to sign, so it was agreed 2 degrees centigrade. So that was the thing, that we have to keep the rise in temperature below 2 degrees centigrade. This was decided. Otherwise, if we don't do anything, as I thought, there will be drought situation at many places, sea level will rise, many island countries may be finished, they will be underwater if sea level will rise. Many coastal cities will be underwater. You know what happened in Louisiana and New York also, sea level will rise, so many communities will be finished. So that is the main problem. So what was there in that agreement? That $100 billion every year has to be raised for different projects fighting against the climate change, to reduce the production of greenhouse gases. $100 billion every year has to be raised, and every country has to keep the record what they are doing, how much they are investing. So at that time, China was the biggest polluter 10 years ago, and now also I think China is, because I was traveling in China, different cities, Beijing, places, other Shandong, and there was a pollution as bad as in Delhi. Okay, so China is polluting, 20% pollution of the whole world comes from China. And then United States around more than 17%, and Russia 7.5%, European Union 9%, India 4.1%, Canada 1.95%. So at the time, while signing the Paris Agreement, they made a list and they mentioned this thing, which country is polluting how much. Then in 2021, COP26 was organized in Glasgow, and there they agreed that instead of 2 degrees centigrade, we should keep the limit at 1.5 degrees centigrade. And it was considered very serious matter at that time, that 2 degrees centigrade is not enough, we should go for 1.5 degrees centigrade. In Glasgow agreement they signed, and by mid-century we should have the net zero, global net zero. So global net zero means total emissions are equal to or less than emissions removed from the environment. That is global. So by 2050, mid-century means around 2050, that was agreed. So 200 countries signed the Glasgow Agreement. So there were other things in Glasgow Agreement, I will not go, you can just see. And $100 billion was still there, $100 billion every year has to be raised. Then last year in November 2024, in Azerbaijan there was COP29 took place. And again in COP29 they emphasized that we have to keep 1.5 degrees centigrade. And another interesting thing was that every year $300 billion has to be raised starting 2035, $300 billion. And that money should come from developed countries to provide money to poor countries so they can fight the climate change. But I don't know what, recently this COP30 took place in Brazil, so I am not aware what is happening there, but this is what happened last year in Azerbaijan. Now, if you see the situation in Canada, if you go in the north of Canada, so much ice and snow, people can make igloo and live inside it to protect themselves from the wind. So, and then in Montreal, many times, it has not happened after this COVID, but before COVID, every year there was a ice village used to be formed in Montreal. There's an island. Montreal is an island, and there are very small island there. Montreal is surrounded by the St. Lawrence River. St. Lawrence River is a very big river, and there is a small island. There, big national park is there, and there they organize ice village. Every 2 years they organize ice village. So what is there in the ice village? You will have big size, full size hotel made of solid ice. And there are rooms. You can go, you can rent a room there in that hotel, $200, $300 a night. And that room is made of total solid ice. Your bed will be made of solid ice. Table and chairs made of solid ice. Even the wall hangings, beautiful, colorful painting made of solid ice. And then you go to bar area and you can have a beer in a solid ice mug. You can have beer in that. And then there is a church, total functioning church made of solid ice. Table and chairs made of solid ice. So it is so interesting. Then you will say, what is this global warming? In Canada, if we have, instead of 2 degrees centigrade, we have +4, +5 degree, it is good for Canada. Because temperature is already so low there. But I tell you, see, these are the photos of the hotels made of solid ice. Big. But I tell you, that is not good for even Canada also, this rise in temperature. Canada has 20% of total fresh water resources of the whole world. So much fresh water resources are there in Canada. And there are so many glaciers. There is one Athabasca Glacier near Calgary. I was doing PhD in Calgary 40 years ago. And we went there to see the Athabasca Glacier. What was that glacier? It was 1,000 feet of solid ice. For hundreds of kilometers, solid ice glacier. So there used to be a big truck with big wheel and those things. They take you to the top of the glacier and you can go and stand on the 1,000 feet of solid ice, and if you go in summer, sometime it melts and you can see the water is going somewhere and then suddenly it disappears in some hole or something. So that was the time 40 years ago. And then they had the marking, okay, until 1945 the glacier was up to this point, 1955 glacier was up to this point, then I went there in 1985, so then 1985. So it was more than 1 kilometer, 2 kilometer, 1 or 2 kilometer. At that time, 1985, 1,000 feet of solid ice of hundreds of kilometers was already melted at that time. So you see, the glacier was receding, melting. And then I went to 2007, and then in 2024, last year, again we went. Okay? What happened? Okay. So then we went, me and my wife, we went to Calgary and we drove to Athabasca, that is Athabasca Glacier. So there we saw another miles and miles of glacier is melted. And the guide told us, now it is not 1,000 feet of solid ice. Now it is only 600 feet of solid ice. See, glacier is melting. And all the fresh water comes from those types of glaciers. From Athabasca Glacier, there are 3 rivers. One is the Athabasca River, another is Saskatchewan River, and another is Columbia River. 3 river systems comes out from this glacier. So if this trend continues, maybe in few decades that glacier will be finished. All the glacier will be melted. So from where the fresh water will come? So this is not a good situation even for Canada. If you see this greenhouse gas emissions in Canada, so these are from various sectors, oil and gas, transportation, building, from where this greenhouse emission is taking place. But if you see for electricity generation, greenhouse gas emission taking place for generation of electricity is decreasing. So here you can see this is decreasing in Canada. It means less and less oil and gas and those things we are using, fossil fuel we are using. And if you see the situation in North Canada and Quebec, there are so many remote villages, and in winter time they are buried in snow and ice. They are not connected to the grid. So they are totally dependent on the diesel generators. There are many water pumping stations, they are dependent on diesel generators. There are many mines in the north. They are totally dependent on diesel generators. And then there are communication stations. Okay, telecommunication. Then petroleum station, there are many islands. So there are so many communities. Those are dependent on diesel generators in Canada. So you cannot avoid the, you see, so many communities in the north. They are not connected to the main grid is basically here. Okay, at the border of United States, so most of the big cities are there. So that is not a problem. But in the north, they are not connected to the grid. So they are totally dependent on diesel generators, northern communities. And diesel generator, as you know, it is very inefficient. It generates a lot of greenhouse gases. And the fuel prices are very high. For example, I tell you, I live in Montreal and I am paying 7 cents or 8 cents per kilowatt hour for the electricity. But the price of electricity for these northern communities, in the north of Quebec, it costs 43 cents per kilowatt hour, while I am paying 7 cents, 8 cents per kilowatt hour. And in some communities further in the north of Canada, they pay 90 cents, 92 cents per kilowatt hour for the electricity. So in the Quebec and northern Quebec communities, the cost of electricity is 43 cents per kilowatt hour. But those are the poor communities, poor people. How can they pay that much money? So Hydro-Quebec has the obligation to provide electricity to all citizens at the same price. So they cannot ask 42, 43 cents from those poor people while I am paying 7 cents or 8 cents. So Hydro-Quebec subsidize. So in that process, every year Hydro-Quebec loses around $150 million to subsidize electricity for those people. Now you will say, why it is not connected to the grid? So according to Hydro-Quebec, few years back they were saying it costs around $1 million per kilometer to put a transmission line. So if there is a community of 200 people around 400, 500 kilometers away, it means for 200 people, you will be putting 500 kilometer line, which will cost you $500 million just for 200 people, which is not economical. So that's why they are keeping using the diesel engines. But now what is happening is that there are projects, we are trying to integrate the renewable energy with diesel generators. So that's why the system we are talking about, hybrid standalone renewable energy system. So diesel engine, first thing is to increase the efficiency of diesel engines. So as you can see, there are two types of diesel engines: fixed speed diesel engines and variable speed diesel engines. So fixed speed diesel engines, this technology is there for many decades. Okay, it's or simple technology, but there are some drawbacks that most of the time it runs at a light load. So if it is running at light load, efficiency is very poor, fuel consumption is lot, and it makes lot of noise, and it generates greenhouse gases. So there are some problems with fixed speed diesel generators. So a lot of work is going on variable speed diesel generators. So what are the advantages of variable speed diesel generator? Reduce fuel consumption, increase conversion efficiency. Those are the advantages of variable speed diesel generators. So as you can see in this diagram, this is the percent of load, and here the fuel consumption, percent of fuel consumption. Suppose the diesel generator is loaded at 100% capacity, then efficiency is very good. But if you reduce the load, suppose you have 30% load, you have 30% load, still you have 50% of fuel consumption with fixed speed operation. So red line is fixed speed operation, blue line is variable speed operation of diesel engine. So if you have a variable speed operation, if you have 30% fuel consumption, so there is a big advantage. There are a lot of savings if you are using variable speed diesel generators. So this is what it is being done nowadays. For last 10-15 years, the Canadian government, we are trying to integrate the renewable energy with the diesel generators. So renewable consumption of diesel generators, diesel, so that it will cost less. Okay, so if you see the wind profile or sun profile, then I will show you this slide. In the north of Canada, wind profile is reasonably good. So diesel generator started now. What? Okay. Diesel generator is on now. Okay. So if you see the wind profile in Canada, it is not that great, but still it is very good. Especially in the north of Canada, the wind is very nice. So I will show you in the diagram that if you, at many places in the north of Canada, we have around 1000 watt per meter square of wind. अच्छा ये ऑन करना पड़ेगा. So remote से on करना पड़ता है. Okay. So at many places in the north of Canada, you can have, with the wind energy, you can have more than 1000 watt per meter square, which is reasonably good. And in the south of Canada also, it may be 500-600 watt per meter square, which is reasonably good. This is the wind profile. So you can see in the north of Canada, wind is reasonably good, and here you can see around 800-900,000 watt per meter square of wind energy generation. And if you see the solar radiations, colors are not right, but it is okay. Solar radiations in Canada. In the south of Canada, solar radiations are reasonably good, and as you can see, that 1400, 1500 kilowatt hour per kilowatt of installation. Suppose if you install 1 kilowatt of solar panel, then in 1 year you can have 1400, 1500 kilowatt hour per year. So this is what it is. But in the north of Canada also it is not that bad. In the north of Canada you can have around 1000 or more than 1000, 1100 kilowatt hour per kilowatt of solar potential, yearly solar potential. If you see the installed capacity, so wind power capacity in Canada is around 15,000 megawatt total wind, and total solar capacity around 6,500 megawatt capacity. And if you see the province of Quebec, this is the Quebec. In Quebec, wind energy is around 4,000 megawatt. So as I told you earlier, in Quebec, we have 40,000 megawatt of hydropower and 4,000 megawatt of wind power. So 100% we have renewable energy in the province of Quebec. And then you will see how much is the solar? 15 megawatt. So I told you the reason yesterday what is happening. But in other provinces, we have around 2,800 megawatt of solar. See, it is not that bad in other provinces. In Ontario, this is Ontario, we have 5,500 megawatt of wind energy. So as I was telling you, we will say, okay, in India, we will see the data. Okay, we will see the data later on. If you see the wind, total world wind energy installed, it is more than 1 terawatt of wind energy installed in the whole world. Okay. And if you see in China, this is 2023 data. In China, you have 442,000 megawatt of wind energy. But here in this slide, it is in India 44,736 megawatt. But I was checking yesterday on internet that in October in India, installed wind energy capacity in October 2025, it has reached more than 53 gigawatt, 53,000 megawatt in India. Wind energy, wind turbines are installed. And in China, wind energy capacity 520 gigawatt of wind energy. So it is much more than this. If you see the solar power installed in the whole world, 1.4 terawatts in 2023. And if you see here, China has around 610,000 megawatt of solar installation. So yesterday I was checking, because this is 2023 data, but I was checking on internet yesterday. In October 2025, India's installed solar power capacity was 129,000 megawatt. So much more than whatever is given in this curve, because for the last 2 years, lot of development in India and in China, 1.1 terawatt. So this is what happened. I was showing this slide in China to some engineers in a company and in some universities. So they were objecting, no, this is not right. We have already caused 1 terawatt of solar installation, and they were perhaps right. So this is what the information I got. So a lot of work is going on in India and China. Now, what are the problems related to the intermittence of the renewable energy sources? because with the temperature, humidity, altitude, topography, atmospheric pressure, all these they impact on wind speed. Thus, the quality of prediction of the power produced by wind turbine is highly dependent on prediction of wind speed. So that's the problem. Wind speed is fluctuating and unpredictable, and at the same time load is also changing. So you see, wind speed is changing, load is changing. So basically they are not compatible. You cannot connect directly the wind energy to the grid. Same thing is the photovoltaic output. Sometime sun is there, sometime cloud is there, sometime pollution there, so less energy reaching to the solar pollution. So, and in the night time there is no sun also. So that's the problem. So that's why renewable power need processing using power electronic converters before being fed to the consumers. So energy supplied by renewable energy, so needs a DC or AC conversion before being injected to the microgrid, because consumer needs regulated voltage and frequency. So you need power converters. We have seen yesterday so many power converters you use to integrate wind energy and solar energy to the grid. Although there are some losses in power converters, but after all this is a free energy, so it is not a big thing. And on top of that you have multifunctional capabilities of power converter. So as I was telling yesterday, that it is not just power converter transferring the wind energy or solar energy to the grid, interfacing it, but at the same time your interfacing inverter converter taking care of the power quality on the grid. They can have, you can have harmonic compensation, right? You can have voltage regulation, reactive power compensation, load balancing, so many things you can do with a single inverter. So this is what I always tell my students doing research in this area, that you just don't have to see how much power is transferred, but it has to take care of multi capabilities. It has to take care of many problems, to solve many problems on the grid, because most of the time your converter inverter is not loaded to the full capacity. So most of the time it is 50, 60, maximum 60% capacity. So rest of the capacity you can use to improve the power quality problems on the grid. Then if you see the desirable characteristic of electrical machines for renewable energy, it should have a high efficiency over wide torque and speed ranges, high power density, wide speed range, high reliability, maintenance free. So these are the quality you look for the machines which you are using for generation in wind. High robustness, good voltage regulation, high power factor, low cost. So all these are the desirable characteristics of the electrical machine used for the renewable energy. You already know so many different types of generators are available, which are already being used by different wind farms around the world. You know, squirrel cage induction generator, it is very robust, right? So, and cheap. So it is being used a lot. But however, you know, there is a problem that you cannot have the speed control there through the rotor. So basically it is difficult to have MPPT, maximum power point tracking, with those, unless you use a full size back-to-back converter on the stator. Then it will increase the cost of the system, right? And then if you have a wound rotor synchronous generator, this is the classic machine. So on the rotor side, you have two slip rings and two bushes, and you can control the active and reactive power here at the terminals. But then here again, you have to connect, because if it is connected with the wind turbine like this, the speed will be variable. then the voltage and frequency here will be variable, right? So you need full size back-to-back converters to connect it to the grid. Now doubly fed induction generator, yesterday we saw it in detail, that on the rotor side you have 3 slip rings and 3 brushes, and here you have 2 back-to-back converters, and then it is directly connected to the grid. This is what we discussed yesterday, right? This is a grid here. But the advantage here is that these back-to-back converter are around 1/3 capacity of the machine. So like Hydro-Quebec started with 1.5 megawatt size doubly fed induction, because in Quebec, the Hydro-Quebec is using doubly fed induction generator for all the wind farm to generate 4,000 megawatt of wind energy. Initially, they started in 2007 with 1.5 megawatt machines with 500 kilowatt, 2 back-to-back converters. But then with the development of technology, the FIG machine, they started using 2.6 megawatt, and now they are using 3.6 megawatt of doubly fed induction generator in the system. And then PMSG, like yesterday we discussed, you have permanent magnets here, and then because with the variable wind, the frequency will change here, so you need two full size back-to-back converter. So if this machine is of 5 megawatt capacity, you need 5 megawatt capacity this converter and 5 megawatt this converter, so it will increase the cost. And on top of that, you have permanent magnet, which may increase the cost of the machine. So overall cost of the machine is increased. So this is what actually, it depends how much money you have, how many machines you have bought, how you can negotiate with the company which is providing PMSGs and those things. So this all depends on that. And then another type of machine, synchronous reluctance machine, which is becoming very popular, and it's available in this capacity, 0.75 kilowatt to 450 kilowatt, made by ABB. I think now ABB, at some places they have changed the name Hitachi Energy, but perhaps this motor. So this has lot of advantages. Stator is same as that of 3-phase induction machine or synchronous machine. Rotor is salient pole construction. Saliency is created by the flux barrier of high reluctance path. So you see, these are flux barriers here, so which creates the saliency here. Okay, robust construction, less losses than induction generator as rotor rotates at synchronous speed. Okay, thus rotor currents are negligible. Rotor is completely magnet free, so this is a big advantage. So this is cheaper than PMSGs. Procedure of voltage buildup is same as self-excited induction generator. External capacitor is required. And then I was visiting in China, and there is a work going on to improve the performance of synchronous reluctance machine. And although I also have one PhD student, girl PhD student, she is also trying to improve the performance of a synchronous reluctance machine as a generator or a motor by putting a little bit permanent magnet here, a small amount of permanent magnet here. So this is what is called permanent magnet assisted synchronous reluctance machine. Many researchers are working in this direction because this machine is cheaper, and if you put little bit permanent magnet on those things, so it gives very good performance. So my student is also working in this area, and she just started 1 year ago, and she is doing good. And then I was visiting China also. China, they are working also on the same type, like to improve the performance of synchronous reluctance machine. So if you see the wind energy exploitation technologies, type A, type B, I think yesterday also we were discussing about the type C and type D. Type A, you see this is squirrel cage induction generator, right? And you have this wind turbine gearbox you need, and either you can connect it directly to the grid. But to have a soft start, because you already know that induction generator or motor, when you start, it takes 5 to 6 times of rated stator current. So it draws a lot of current, reactive current from the network. It may generate voltage sag condition, as we discussed the first day, this thing. So to have a soft start, you can have this, and once it starts, then you can bypass this converter. Okay, so this is type A. Type B, so again the same problem, that it is difficult to have MPPT with this type of machine because you cannot vary the speed. Now type B, this is wound rotor induction generator. So the same thing, the only thing is that you have 3-phase variable resistance in the rotor circuit, right? We were discussing yesterday, so it will change the characteristic in first quadrant and second quadrant. First quadrant is working as a motor, second quadrant working as a generator. So we were seeing that characteristic like this. This is first quadrant, this is second quadrant, third quadrant, and fourth quadrant. This is motor, generator, something like this, as you have studied in your undergraduation. And with the resistance in the rotor circuit, it will change the characteristic like this. So you see what basically you are doing. This is the, you are using this machine as a generator. So for MPPT, you are exchanging the range. You are having the range of speed where you can do MPPT by putting extra resistance in the rotor circuit.